Electricity is a fascinating force that powers so much of what we use every day, from lights to phones to computers. But how does electricity move through wires and circuits? To understand this, we need to learn about Kirchhoff's laws. Kirchhoff's laws are two fundamental rules that describe how electric currents behave in circuits. These laws were discovered by a brilliant scientist named Gustav Kirchhoff in the mid-19th century. They are essential for understanding and analyzing electrical circuits. Imagine you have a water pipe with multiple branches. When water flows into the pipe, the amount of water that goes into each branch must equal the amount that comes out. Similarly, in an electrical circuit, the total amount of electric charge provided by the battery must equal the total amount required by the load. This is known as Kirchhoff's first law, also called the law of conservation of charge. Basically, it states that the amount of electric charge in a circuit is neither increased nor destroyed. Now, let's think about a loop in a circuit. A loop is like a pathway that electricity can follow, starting and ending at the same point. As electric charge moves around the circuit, voltage may change due to components that absorb it. Kirchhoff's second law, often called the loop rule or Kirchhoff's voltage law, states that the sum of these voltage changes in a closed loop must add up to zero. Let's use a simple circuit to illustrate these laws. Imagine you have a circuit with a battery, a resistor, and a light bulb connected in a loop. At any junction in the circuit, the total amount of electric charge flowing in must equal the total flowing out. It's just like a traffic intersection, where the number of cars entering corresponds to the number of cars leaving. This ensures that charge is not created or destroyed. It simply flows through the circuit. This is exactly what Kirchhoff's first law states. As electricity flows around the circuit, it encounters different components, resistors, capacitors, bulbs, etc. Each component causes a change in voltage. According to Kirchhoff's second law, when we sum all these changes in voltage around a closed circuit, the result must be zero. In other words, the total amount of energy supplied by the battery corresponds to the energy consumed by the components in the circuit. Now that we understand the basic principles of Kirchhoff's laws, let's see how we can apply them to solve problems in circuits. If we consider the connection, we basically have just two types of circuits, series and parallel. Let's consider a simple circuit with a battery and 3 resistors. In series circuits, the components are connected one after the other. The voltage provided by the battery changes every time it is absorbed by the components. The total voltage amounts to the sum of the voltage drops across each resistor. What happens to the resistance? In this case, the total resistance in the circuit corresponds to the sum of the resistances of the individual resistors. By using Kirchhoff's laws, we can calculate both the current and the voltage across each resistor. Now, let's consider a circuit with the same components but connected in parallel. This means that each of the 3 resistors is connected to the battery. In a parallel circuit, the voltage across each resistor doesn't drop. It remains the same and corresponds to the voltage provided by the battery. How do we calculate the current? Kirchhoff's laws tell us that the total current flowing into the circuit equals the sum of the currents flowing through each resistor. Kirchhoff's laws are not just theoretical concepts. They have practical applications in various fields, including electronic circuit design, power distribution systems, and circuit troubleshooting. Engineers use Kirchhoff's laws to design and analyze complex electronic circuits, such as those found in computers, smartphones, and other devices. Kirchhoff's laws are also used in the design and maintenance of power distribution systems, ensuring that electricity is efficiently delivered to homes and businesses. And lastly, when there's a problem with an electrical circuit, technicians can use Kirchhoff's laws to identify and fix issues, such as short circuits or open circuits. In conclusion, Kirchhoff's laws are fundamental principles that govern the behavior of electric currents in circuits. By understanding these laws, we can analyze and solve problems in electrical circuits, from simple household circuits to complex electronic devices. Simply put, Kirchhoff's laws are essential tools for understanding and working with electricity.